Hello, good afternoon. So today basically we are going to start the next chapter, chapter 15, and we are going to start with Pythagoras Theorem. This is fairly straightforward, it's fairly simple. So I'm just going to explain basically how to use it and how it works and where it works. And then maybe once we are in class together, we may actually prove where it comes from. You don't need to know the proof, you just need to be able to use it to find missing sides. So I'm going to switch now to a picture, and we're going to use that as an example on how it works and why it works. All right. Okay, so let's get ready. Here we go. Okay, so here we are. Basically, Pythagoras theorem can be used to find missing lengths of sides in right-angled triangles, and it only works in right-angled triangles. So, I don't want to see anyone ever trying to use Pythagoras theorem in any triangle that is not a right-angled triangle. So, what Pythagoras theorem says, Pythagoras being our good old ancient Greek mathematician, is that, and these, you may see different letters in different books, but it doesn't matter, is that h square equals a square plus b square. That's Pythagoras theorem. Now, what's h, what's a, and what is b? So a and b, it doesn't matter which one is a, which one is b. A and b are the two shorter sides in a right angle triangle. So the two sides that meet at the right angle are the two shorter sides. So one is a, one is b. The side opposite the right angle is always going to be the longest one, and it's got a funky name. It's called the hypotenuse. So hypotenuse. That's meant to be an E between the T and the N. Sorry for the awful handwriting. Using my finger, haven't got a proper pen. So anyway, that's that. So A and B, always the shorter sides, always meeting at the right angle, and hypotenuse always opposite the right side. Okay, so what this is telling me, Pythagoras theorem, is that if I knew the lengths of the sides, so let's say that B was 8 centimeters long and that A was 6 centimeters long, I can use the theorem to find the length of h. So I will just substitute my values. So h square equals 8 square plus 6 square. So h square is 64 plus 36. So h square is 100. So what's h? Well, then h is going to be the square root of 100, because the opposite of squaring is square rooting. Therefore h must be 10 centimeters. And that is it. That's how you use Pythagoras theorem to find the hypotenuse. Now, more often than not, your answer is going to be a decimal, in which case you should round your answer to 1 or 2 decimals, depending on what the question says. So do not be scared if, like I said, more often than not, your answer has got a decimal in there. Now, we can also use Pythagoras theorem to find one of the shorter sides. So I want to do that. Now we can use Pythagoras theorem to find one of the shorter sides. So remember, Pythagoras theorem says that h square equals a square plus b square. Let's assume that now they tell me the length of here is 5, that's the hypotenuse, always the longest side, always opposite the right angle, and this one here is 10 centimeters long, so this is going to be all in centimeters, and I gotta find that length there. I'm just going to apply Pythagoras theorem and substitute in there. So h is 15, so 15 square is going to equal 10 square plus x square, which means that 15 square, I believe, is 225, but I'm just gonna get my calculator out, make sure everything is right. 15 square, that's right. So 225 equals 100 plus x square, which means that x square is going to be 225 minus 100, because when the 100 goes to the other side of the equation, it goes with a minus, so 125. Therefore x equals the square root of 125, and the square root of 125 is 11.2 centimeters if I round to one decimal place. Remember, you're trying to find one of the shorter sides. If for whatever the reason, think about it and use your brain. If for whatever the reason your answer is greater than 15, you know you've gone wrong, because the hypotenuse always has to be the longer side. So anyway, that's it. That's Pythagoras theorem at the most basic level. We will obviously complicate it as we go forward. We will apply it in 3D. The questions will get much more complicated, but for now, that's it. Remember that you're going to need your calculator, and try hard, work hard, and I'll see you next time. Bye.